Okay, y'all. I'm not used to presenting and recording at home, so I probably will go a little faster. Let me make sure this should be presenting the right slide. Let me just make sure because I'm not used to doing it this way. I need to pin. There we go. I want to pin that. Okay, this all should be recording right. I'll double check it before I post it into YouTube, and hopefully I don't have any little typos for my fourth period. You know full well you're the class that I catch it in. Hopefully my kid doesn't run in here and the cat doesn't stomp on the board or on the keyboard. But yesterday we looked at balancing equations, but not combustions. And there was one, and I don't have the paper in front of me, of course. There was one that wasn't a combustion that had a polyatomic on one side of the arrow, but not on the other. And the rule of thumb is if there's a polyatomic on both sides of that arrow, you leave them together. Okay, you hush. You balance them like a unit. But if the polyatomic is on one side and not the other, then you have to break it apart. And I'm going to show you how to take care of that problem. So hopefully you could do the ones that were not combustion, and then that one problem that had a poly on one side and not the other, you should have been able to have done most of the others. Remember, I'm going to be here tomorrow, and tomorrow is a what are we having problems with day tomorrow. For those of you that are ahead, there is another page for tomorrow, but it's all the same stuff. So for the opener today, it says, why do you think combustion balancing is so much harder than normal skeleton equations? Now, obviously, oh, shoot, my screen just tapped out. Uh-oh, hold on, I gotta get back to the right slide. I don't think you guys can see what just happened. So I have a combustion equation in front of you. Now, sometimes oxygen is in your fuel and sometimes it's not. But you're going to have a certain number of hydrogens. Y just represents a subscript. And you're going to have a certain number of carbons. It might be 1, it might be 2, but it might be 6 in the case of sugar. But you're going to have a hydrocarbon. It needs oxygen to burn. So these are your reactants. And then you have your combustion reaction that occurs. And they're going to almost always produce carbon dioxide and water. This is a typical combustion reaction. So since I don't have you guys to respond to me, the reason why combustions are so much more difficult is you may have 2 different sources of oxygen as a reactant. You're definitely going to have at least 2 different sources of oxygen as a product. And what people try to do is they try to go ahead and add them together and then balance them, but you can't. If you put a number here, that's only going to affect the oxygen and the carbon dioxide. If I put a number here, it's only going to affect the oxygen in the water. So you cannot already add them together until you're trying to get a final answer and make sure if your reactants and your products equal out to the same. Okay, so there is no extra paper. The notes themselves, I left some behind for those of you that want to do paper, but this is to finish the paper from Wednesday. So notes 31, part 2. Combustions, and we have to split a polyatomic from one side to the other. So the answer to the focus, what makes a combustion more difficult? And more often than not, the only type of reaction that I actually have to work out longhand is a combustion. What makes them hard is the fact that there are multiple sources of oxygen, which I just answered in the opener, that you've got that plus sign, and you have to deal with the oxygens like it's not even algebra, it's just adding. But I will walk through a couple of these and I will try to go as slow as possible. If I'm going too fast, just pause this and go back and fill it in. But a skeleton equation, besides a combustion, a regular skeleton equation, if you have a poly on one side, like carbonate, CO3, but it's not on the right side. So just the reactants has CO3, whether it's got parentheses or not, I don't care. You have carbonate on the reactant side, but there is no CO3 on the right-hand side. There might be carbon dioxide and something else, but you don't have the same polyatomic. You have to balance the carbons separate from the oxygens in that case. You would have If it's just one carbonate, you would have one carbon and 3 oxygens on the reactant side. And then you're going to have to look at the product side, how many carbons and how many oxygens. If they're on both sides, this is one of those, please just trust your teacher because this will make your life easier in chemistry. If they are on both sides, leave them together. If it's on one side and not the other, that's when you have to split them apart into the oxygen, well, in most cases, the oxygen and whatever else it has. When you have a combustion, if you have oxygen in your fuel source, in your hydrocarbon, your CH, whatever, if it's one oxygen by itself, or if there's 3 oxygens, if it's odd, 1, 3, 5, 7, 9, whatever, more often than not, you can start by doubling that compound. It might have to be times 4 or times 6 or times 8, but you can make an odd number even because we multiply by an even number, but you can't make an even number odd because there is no such thing as division with balancing. These coefficients, the numbers in the front, all they do is multiply. The same order that we did them yesterday, we read from left to right. You're going to balance them in the order that you see them on the reactant side. I don't care what order they are on the product side. You're going to list them in order on the reactants, and you're going to duplicate that same order on the product side. If you have hydrogen on the very top of the reactant side, it's going to be hydrogen the very top on the product side. And you're going to list them in the same order. Please trust me, if you mix them up, you will get confused. So keep them in the same order when you're working them underneath the equation. And then you go back and you pay attention to the subscripts to identify how many you have of each. So not only do we work from left to right, but we work from top to bottom because that is the way that we read things with English. Once again, don't already add multiple sources of elements. Separate them with a plus sign if there is a plus sign either on the reactant or on the product side. With a combustion, and I'll go through when we work these, your water on the product side, if there are absolutely no extra oxygens in your fuel, it's just a C number, H number plus O2. And then on the right-hand side, you have the water. So you have CO2, which is even, plus the water, which is odd. If you put a number in front of that water, it has to be an even value. If you put an odd value in front of that water, a 3, a 5, a 7, whatever, you're still going to have an odd value. So when you look at the hydrogens on the reactant side in a combustion, you figure out whatever number would fix it with the water. And let's say that number would be, let's say you had 6 hydrogens on the reactant and you had 2 hydrogens in the water. You go, oh, okay, well, I need to put a 3 in front of the water, except for the fact that that makes that odd. Double it. So instead of a 3, you would do a 6. If you put a 5 in front of the hydrogen in the water, and there's no odd sources on the other side, instead of a 5, multiply it by 10. Because once again, you can make an odd number even, but you cannot make an even number odd. So here's going to be the example, and this is exactly how I would have worked this in front of you. I see carbon first, I see hydrogen second, and I see oxygen third. There are no oxygens on my reactant side. So then I draw my line. Then I make sure that I do carbon, hydrogen, and oxygen. Y'all, I don't care what order they are up here. Keep them the same order, just like we did before. It's just now we have combustions. Now you come back and you figure out how many you have. I have 4 carbons. I have 8 hydrogens. And on the reactant side, I have 2 oxygens. Now I'm going to come over to the product side. I have 1 carbon. There's no subscript, so that means 1. Now I got to don't do oxygen next. Do hydrogen next. I have 2 hydrogens. And then I have to write it the way I see it. I have 2 plus 1 oxygens. Yes, I understand that adds up to 3, but don't write 3. Because once again, if you put a number here, it only multiplies the 2 oxygen. If you put a number here, it only multiplies the 1 oxygen. Now, so we go left to right, top to bottom. Now, the first thing I'm going to check is if well, there's no extra oxygens here. So I know that this has to end up being an even value. So I have 8 hydrogens. If I put a number here and it's even, then that's awesome. I'm just going to start top to bottom like I told you how to do yesterday. However, if whatever this is, the number I put here is odd, you're actually going to have to double that. So so since that's going to be an even number, I'm just going to start at the top. I have 4 carbons on the left. I have 1 carbon on the right. So since all I can do is multiply, the lowest number that I can make them both is 4. This multiplication, not the total, this multiplication number has to go in front of the compound that has carbon, which is the carbon dioxide. Now, this is what you guys forget to do as a whole. You have to distribute. It doesn't just multiply the carbon, it multiplies the 2 oxygen. So that's this one. 2 times 4 is 8. I'm still not going to add. Okay, so just like yesterday, once you change numbers, you start back over from the top. So 4 is equal to 4. Awesome. Okay, well, 8 is not equal to 2. I want them to both be the same number, the same smallest number evenly, which happens to be a total of 8. 8 times 1 is 8. 2 times 4. Once again, it's the multiplication number that goes in front of the compound. So 4 times 2 is 8 hydrogens. 4 times 1 is 4 oxygens. So I'm just going to go back and double check, make sure I didn't mess anything up. 4 is equal to 4. Great. 8 is equal to 8. Perfect. Now I can add these two numbers. 8 plus 4 is 12. So somehow I got to fix this oxygen. I got to put something in front of it to make it 12. And the number that will do that is 6. Now, some teachers teach this differently. I personally was always taught that once everything is right, and you can always double check, 4 is equal to 4, 8 is equal to 8, 12 is equal to 12, which means any missing values that are left over get a 1. I personally write ones as coefficients. It's the way I was taught. I have seen some teachers not. I don't write ones as subscripts. I do write ones as positive and negative charges. Some teachers don't. Some teachers just use a plus or a minus. If there's no number, it means 1. It's just the personal way that I was educated on how to do chemistry. This would be where I ask if you have questions, but you're not here with me. So I'm going to go to the next one. Oh, and this is obviously a combustion reaction. Oh, I didn't animate my arrow. Poop. Oh, well. It's not this. That's the only thing that I catch doing this as a dry run. I'm gonna be thankful. So carbon, hydrogen, oxygen, carbon, hydrogen, oxygen. That's the first thing you should do. You draw the drop down line. You need to be equal on both sides of it. This is just to help to separate it on either side of the arrow. And then I've got, in this case, I've got 2 carbons. I've got 6 hydrogens. And I've got 2 oxygens, and this is only on the reactant side. This side is the product side. I've got 1 carbon. I've got 2 hydrogens, and once again, I have 2 plus 1 for my oxygens. Now, here comes the part I was talking about that we didn't have to do last time. If I look at this hydrogen source, I have 6. I have 2 over here. If I put a 3 in front of this water, I'm still going to have an odd value, and I can't have that. I need to make this even because I don't have an extra oxygen over here. So I am going to, instead of a 3, I am going to double it as a 6. Now, there's nothing wrong with doing this the long way and coming back and going, oh, man, this doesn't work, and I have to double stuff. I just have trained my brain that when I change my hydrogens, whatever I put here to multiply, if this is still going to make that oxygen odd, you normally double it. Sometimes you have to quadruple it. what would 6 be? Sextuple it? I think is how you would say that. I don't know. But in this case, I have to double that 3, which is a 6. I need to distribute it to the hydrogen. So 2 times 6 is 12. Now I'm not going to change the carbon yet. I know that value of hydrogen has to change in order to fix it over here. So now I'm going to do hydrogen next. I want them to both be 12. 6 times 2 is 12. This 2 is going to go up here. Doesn't just leapfrog to the hydrogen, it also multiplies the carbon. So now I have 4. That is why I did not start with carbon. There is not, y'all, please use pencil. There is nothing wrong with going back and changing the coefficients if you have to. I know the shortcuts to be able to balance, and this happens to be one of them. So now I want them both to be 4. So 1 times 4 is 4. This multiplication number comes up. This multiplies the 2 oxygen. And 4 times 2 is 8. So now I'm going to double check. 4 is 4. I'm good. 12 is 12. I'm good. 2 is not what this is. So now I get to add these. 8 plus 6 is 14. So in order to make 2 times x equals 14, that magic number is 7. And this 7 goes up in front of the oxygen. I do not have any holes that I need to fill in with a 1. Once again, this is a combustion reaction. Like I said, if you need to go back and rewatch it once you've written everything down, I like to do things in different colors. It lets you know how they're related to each other. You can do that if you want to, or maybe you can like write like a number 1 with a circle. This is step 1, or a 2 with a circle. This is step 2. However helps you understand this, that's fine. Or you could always try to go to either Khan or Khan Academy. I don't know how do you pronounce it. It's either K-A-H-N or K-H-A-N. He does really, really well tutorial lessons that help in doing this kind of stuff too. Another combustion, I forgot to animate my arrow. All right, so two typos so far. Once again, CHO, CHO. I have 5. Oh, that should say 5, not 2. Okay, I'm going to stop this. I'm going to fix it so you cannot see what I am doing. 5, 10, I gotta fix my typo, but I don't want you guys seeing what I'm doing. It's what happens when I don't proofread. When I don't proofread my stuff before I try to show it to you guys. 4th period, like I said, you are very used to doing that, dealing with my typos. It's an easy fix for me. That would be this. Okay, let me see here. Is that supposed to be a 2? Okay, I need to go back and fix this. I made a boo-boo. Hold on. Let me go into my original worksheet. I think I copied it the wrong way from my original sheet. Let me look and see. C5 or C2. Dang it. I bet you I made my mistake here because it won't balance right the other way. Let me double check. So put that there. Give me a second. I'm talking through the thing. That's that. That would be, okay, I see what I did wrong. One brief second while I fix my problem. I was looking at it and I was getting all even numbers, and that is not valid. So like I said yesterday, if when you balance this, you get all even values, you need to reduce it. Okay, now let me re-show what I was doing. Tab, chemical reactions. Okay, now that I fixed my boo-boo. Okay, so we have 5, 10, and 2. I had the number 2 there. That was just a mistake on my part. I wouldn't pay attention, but I have 10 hydrogens. I have 2 oxygens. I have 1 carbon. I have 2 hydrogens, and I have my infamous 2 + 1 for my oxygens because I have to balance them separately. There are no oxygens here. Okay, so there's 10 and 2. So naturally you say, oh, that's times 5. But if I put a 5 here, that still gives me an odd. So I'm going to start by doubling that value. So 5 times 2 is 10. So it does times the hydrogen, okay, and it does times that single oxygen. I should have animated this one before this one, but it's no huge. It still ends up being the same thing because it distributes. So I know everything is all messed up, okay, but I'm going to now fix the hydrogen. Okay, so I have 20 over here. 10 times 2 is 20. This 2 will go up in front of my hydrocarbon, but then I have to distribute. All right, so now the only thing that I have successfully fixed is my hydrogen. Everything else is messed up. So I'm going to start over from the top. No, dogs, don't bark. Hey, no. Patty, no. Ah, sorry, my dog. He sees somebody walking in the front yard. He's not happy. So in order to make these the same number, the smallest one, I'm going to do 1 times 10 is 10. This 10 will go in front of the carbon, which will distribute to the 2 oxygen. Now this is where I had made my typo. I didn't add these 2 numbers right because, yeah. So 10 is 10 and 20 is 20. Now comes the time to fix the oxygen. 20 plus 10 is 30. 2 times 15 is 30, and this 15 will go up in front of that oxygen gas. I do not have any ones to fill in, and once again, this is still a combustion. What my mistake was instead of the 5, I had put a 2 here, and it messed up all my math, but it was an easy enough fix. And I don't want to show you the wrong way to do it. That's why I sort of took it off of presentation mode there real quick and then put it back. Oh, and if I was echoing there for a second, I apologize because it looked like the presentation was doing its own thing as well. All right, so now we're going to talk about what happens when you have a polyatomic on one side and not on the other. What I mean is, and it just so happened to be the example that I was talking about at the beginning, this carbonate ion, oops, didn't mean to do that. This carbonate ion, yeah, I've got carbon over here and I've got oxygen over here, but they're not stuck together. So I still do things in the order left to right. So I've got 1 hydrogen, I've got 1 chlorine, I've got 1 calcium. Now this is where I have to split it. I have 1 carbon, excuse me, and I have 3 oxygens. You cannot balance it as a polyatomic because it's on one side. Just make sure you keep them in the same order. So hydrogen, chlorine, calcium, carbon, oxygen. Just like I said, please just trust me. Please. If you do not, let's say you did calcium, chlorine, the chlorine would be in the right spot, hydrogen, oxygen, and carbon. These, because we like to work things in a line, that is why we are keeping these side by side. I don't care what order they are up here, but I am going to get my numbers from up here. So my hydrogen has 2. My chlorine has 2. The calcium has no subscript, so that is 1. My carbon has 1, and now instead of 2 plus 1, the way it's written is 1 plus 2. We are just going to start at the top and hope that this guy works himself out. And it's not one of those where we need 20s, 30s, 40s for coefficients, which do exist. So starting with hydrogen, I'm going to do 1 times 2 is 2. And the multiplication 2 is going to go in front of the hydrochloric acid or hydrogen chloride, if you're going to name it that way. But I need to distribute it to the chlorine. Okay, so now I get to start over. 2 is equal to 2. Oh, look, 2 is equal to 2. 1 is equal to 1. 1 is equal to 1. And 3 is equal to 1 plus 2. So now it just looked hard. All of those missing numbers are 1s. Just because they look busier does not necessarily mean that they're harder. All I needed, really, and like I said, I personally do write 1s as my coefficients. I do. All I really needed was to double the hydrochloric acid or the hydrogen chloride for you guys that aren't used to the acid nomenclature, and that fixed everybody. I think I've got 1 or 2 more. And then I can't remember if I've got 1 more after this or not. We've got hydrogen, phosphorus, oxygen, same order, hydrogen, phosphorus, oxygen. This is just the boundary between the reactants and the products. I have 3 hydrogens. There's no, and I can't keep it together over here because phosphate does not exist on this side. Ina, girl, do not bark. No. Neighbors are taking their kids for walks. Puppies don't like it. Phosphorus has 1. Oxygen has 4. Right side, the product side. Hydrogen has 4. Phosphorus, oh, well, it's 4 plus 2. We have 2 sources. Your phosphorus has 2, and your oxygen is 7 plus 1. If you can, leave the things that have addition for last and hope and pray that it just works out the right way the first time. So I'm going to start with phosphorus because these guys are ugly. So I know that I can do 1 times 2 is 2. This 2 is going to go in front of the entire compound. So it's also going to change the hydrogen to have 2 times 3 is 6, and the oxygen 2 times 4 is 8. Well, 4 plus 2 is 6. 7 plus 1 is 8. 6 is 6. 2 is 2. 8 is 8. That should have been drug up a little bit. Sorry, that's offline. That means that my missing numbers here are 1s. This is, I didn't put, these last few, I didn't put it. This happens to be a decomposition reaction. You have one thing that is breaking down into multiple parts. In this case, it happens to be 2. Okay, so like I said, I didn't know I was not going to be here today. So this is where I would be like, okay, who's confused? And let's try to fix it. And I'll be here tomorrow to do that. But the reason why the whole closure thing, the reason why we do not add oxygens together first is because we balance them separately. The 2 oxygen in the carbon dioxide is only affected by the coefficient in front of the carbon dioxide. And the 1 oxygen in the water is only going to be affected by a coefficient that goes in front of the water. They don't get balanced at the same time. They are separate. And therefore, in the math below, for those of you that have to keep doing the mathematics below it, there's nothing wrong with that. And like I said, I personally still work out combustions. They're the most difficult of the bunch because of that pesky 2 plus 1 on the right-hand side. You don't add them until you think you're done. And then as long as you have an even addition value on the product side, it's an easy fix on the reactant side. And so once again, I will be here tomorrow. We are doing, this is the opener for tomorrow. We will be working on the paper that was from Wednesday if you still have questions. And then there is another one that will be opened up in Canvas for you guys on Friday. I know some of you have questions. Some of you are catching on really quickly. I will be back tomorrow in order to be able to help you.